Okay, this is the test 3 review video, and first thing I want to note is when you use a calculator formula, make sure you write what you put in the calculator along with your answer. For problems 1 through 4, determine whether the random variable is discrete or continuous. Explain your choice. In each case, state the possible values of the random variable. Let x be the random variable. Okay, so the number of students in a randomly selected elementary school classroom. So keywords here is number of. When you see the number of something, then that means that it's countable, right? So if it's countable, then this is going to be a discrete discrete scenario, and all you have to offer up for explanation is because it is countable. And then for the variables, for this, the smallest number this could be would be 0. It could be 0 kids in a classroom. There could be 1, there could be 2, and so on. Okay. The amount of snow that falls in Minneapolis during the winter season. So amount of snow, this would be a measurement. So for that reason, this is going to be continuous. Did I spell that right? Continuous, yes. Continuous because this is a measurement. It is a measurement. And then for continuous cases, we use the inequalities. So our x can be anything that's greater than or equal to 0, because we're talking about snowfall. It can't be negatives, so it has to be greater than or equal to 0. It could be 0 because there could have no snow that season. The flight time accumulated by a randomly selected Air Force fighter pilot. So this also is continuous because it is a measurement. Because, decimals make sense here, fractions make sense. Measurement, okay. And then for the same reason as number 2, this can be greater than or equal to 0 because we're talking about time. Time could be 0 or positive, but it can't be negative. Here's that keyword again. The number of points scored by the Miami Heat in a randomly selected basketball game. This is discrete because it is countable. Fractions don't make sense here. And then our values of x can be anything from 0, 1, 2, 3, and so on. Okay, make sure that you do study those, because I believe on the first page of my test I have, those questions. So, yeah. Yes, so make sure you study those because you will see those on the very first page of the test. Okay, here's your first extra credit question. Which vocabulary word would be correct to describe the variable hotel ratings of 1 star through 5 stars? All you have to give me is the correct word. You don't have to give me anything extra other than what is the word that would describe this. Revisit your chapter 1 notes for that. Okay, for problems 5 through 6, determine whether the distribution is a discrete probability distribution. If not, state why. So 2 things we have to verify is that our probabilities add up to 1, but more importantly that each of them, I guess not more importantly, it's the same importance, but each one of these has to be between 0 and 1. So first thing, all probabilities are between 0 and 1. The answer is yes. And then the second thing, all probabilities add up to 1. And the answer to that is yes, they do. Of course, you would just put that in your calculator. and add them up. So if both of those are yeses, then you would say that this is a discrete probability distribution. Okay. Yes, on the test it says explain why it is or is not. So it'll be a little bit worded a little bit differently, but yes, determine whether the distribution is a discrete probability distribution, explain why it is or is not a discrete probability distribution. You'll have 2 of those, so make sure you study those. Okay. Number 6, same thing, right? So 1, verify that all of the P of X are between 0 and 1. Yes, they are. So just make sure that each of your probabilities, again, they can't be negative and they can't be anything more than 1. So it can't be 1 point something, otherwise it would not be. And then for the second thing is that all P of X add up to 1. And let's see here. When I add them all up, I actually get 0.73. So that would be a no. So this is not a, and it would just be like a yes, no, like circle yes or no, and then underneath explain. So, you don't have to write this whole sentence. You just circle yes or no. And for, let's see, what did I want to say about this? Oh, I mean, if you find, if it's not a probability distribution and you see that the reason is because it doesn't add up to 1, you don't have to talk about the other one. You can just say not, or you could circle no and say the probabilities don't add up to 1. And I mean, that would be it. You don't have to put both of these down if it's not a probability distribution. You can just explain the one reason why it's not. But if it is, you need to verify both of the cases and say because this is true and this is true. Okay, use the following information for problems 7 through 8. A popular casino table game is 3-card poker. One aspect of the game is the pair plus bet, in which a player is paid a dollar amount for any hand of a pair or better, regardless of the hand the dealer has. The table shows the profit and probability of various hands of a player playing the $5 pair plus bet. What is the expected profit when playing the $5 pair plus bet in 3-card poker? Interpret the result. Don't forget your units. So, so this is, of course, expected profit to the player because they're the ones that are going to be playing this. Expected profit is a keyword. That means you're looking for the expected value. So for expected value, this is when we're going to take, and we're going to make our 2 lists. So you'll see that you have your first list is going to be your profit. This is L1 here. This is L2. And so you're going to do 1 var stats, and you're going to do L1, sorry, list is going to be L1, and then frequency list is L2. Okay, then you will look at X bar, but you're going to write this with E of X, or you can say mu, but it's not going to be X bar. It's one of those 2. And when we plug this in, we're going to get negative 0.12. And it says round to 2 decimal places, so that's why I have that. And then don't forget your units. Oh, it says interpret the result. Dang it, I knew I should have left more space for that. Forgot that part. Okay, so my units are dollars. So negative 0.12, so negative 12 cents is my expected value. And this means that in the long run, so if this game is played many, many times, that in the long run, the player would expect to lose 12 cents per game. So if the game, I don't think I'm having enough room for this, is played many times, the player can expect to lose 12 cents per game. Okay, gonna have to come over here. In the long run. Okay, so really what I'm looking for there is that, you know that the negative means that they're losing that amount of money per game, and then you say in the long run, because this is a long run type of problem. So in the long run is really part of what I'm looking for on that. So lose 12 cents per game in the long run. Those are really the main parts of this. Let me see here. You will have a problem like this. Compute and interpret the expected value from the player's point of view. So similar. Maybe you won't have as many of these things though. You'll also have one like number 8 right after it. And it says, if you play the game for 4 hours with an average of 35 hands per hour, how much would you expect to lose? Okay, so this is going to be quite similar to the one on the test. It is worded a little bit different, but it'll be the same procedure. So if you play the game for 4 hours with an average of 35 hands per hour, that means you're going to be playing a total of, so for 4 hours times 35 games per hour, your hours cancel there. If 4 times 35, which is 140 games, or hands, games or hands, either way you want to say it. And then it says, okay, so you're going to be playing 140 games. How much do you expect to lose overall? Okay, well, if you're losing 12 cents per game, that's why the per game part is important. That means that 140 games times 12 cents per game. Oh, I'm sorry. Let me write this a little bit differently. And it's not 12 cents, it's negative 12 cents. 140 times negative 12 is going to equal negative 16.8. So in other words, you would expect to lose the lose, remember negative becomes the word lose. You're going to lose $16.80. Okay. Here's your second extra credit question. The top speed in kilometers per hour of all the players except goaltenders in the 2014 World Cup soccer tournament is summarized in the table. So up here you've got your speed, so 10 to 13.9, 14 to 17.9, 18 to 21.9, and so on. And then the number of players that would go that speed, right? That would be their top speed. So 4 players reached a top speed between 10 and 13.9, 7 between 14 and 17.9, and so on. Calculate the relative frequency of the third class. So, number them. What order are these classes going in? So I'll give you a hint. This one here, that's your first class. So then find the third class and calculate the relative frequency. Okay, only of the third class. If you want to do it for all of them, that's fine, but all you need is for the third class. Okay. For problems 9 through 10, determine whether the probability experiment represents a binomial experiment. If not, explain why. You will have 2 of these on your test, so make sure that you know these 4 criteria. These are in your on your formula sheets. Grab that. So if you flip over to chapter 6, where we talked about binomial stuff, the binomial requirements is what it says. So let's see here. It says the probability that a randomly selected incoming freshman will graduate from college within 6 years is 0.54. Suppose that 10 incoming freshmen are randomly selected. After 6 years, each student is asked whether he or she graduated. Okay, so the first thing we want to check is that there's a fixed number of trials in the experiment. Trials, or in other words, samples. And the answer to that is yes. The fixed number says that we're talking to 10 incoming freshmen. So n is equal to 10. Okay, so the first one's satisfied. Okay, the second one says the trials are independent. Trials or samples are independent. They are randomly selected, so that means that they're independent. Yes. Randomly selected. Okay, the third thing we're going to verify is that the probability of success on a single trial remains constant. So, probability is fixed. And yes, we have p equals to 0.54. So yes. And then the fourth thing, it says there's only two outcomes. Two outcomes. Graduate. Don't graduate. Yes. Okay, since all of these are yes, this is a binomial experiment. So on your test, when you determine this, you would just say yes, or you can just say yes or no. You don't have to say is a binomial experiment. I mean, I ran out of a little bit of space there, but I'm just going to go ahead and say yes. Okay. An experiment is conducted in which a single die is cast until, okay, you see that word until? This one right here, until. That means that the number of trials that are going to be happening here is not going to be fixed because you're rolling the die until you see a 3. So every time you might be rolling it only 2 times, you may be rolling it 5 times, but it's going to change every single time you do the experiment. So for the very first one, fixed number of trials, that's a no. So this is a no, not a binomial experiment. Okay. Okay, use the following information. Round all probabilities to 4 decimal places. The probability that a randomly selected patient who visits the emergency room will die within 1 year of the visit is 0.05. In a random sample of 25 visitors, find the following. What is the probability that exactly 1 visitor to the ER will die within 1 year? Okay, so for this one, our sample size is going to be 25. So there is a fixed number of samples. It's a random sample, so these are independent. The probability of dying for each person is the same. It's 0.05. And there's only 2 possible outcomes. Either you die or you live. So this is binomial. So there's your n. Your probability, p, is 0.05. And for this one, we want to find the probability that x equals 1, exactly 1. So that's your key phrase there is exactly 1. Okay, when you see exactly 1, that means that you're going to be doing binom PDF. Okay, you use the P whenever it's an equals statement. So on your formula sheet, it says binomial PDF is going to be NPX. Okay, so we will type in binomial PDF. Our N is 25, P is 0.05, and our X is 1. And we will get, sorry, I gotta get my answers, because, you know. There we go. We're gonna get 0.3650. Okay. Notice I did put the binomial PDF part. This part is part of your answer. You have to have that and this. Okay. Let's see. Yeah, you'll have one similar to this, except instead of giving the 0.05, it's actually given as a percentage. So if this set is 5%, you would just convert it to 0.05. So on your test, it'll be actually a percentage. You would just convert that percentage to a decimal. So let's say it was 65%, you would put 0.65. So just make sure you can do that. Okay, what is the probability that at most 6 visitors to the ER will die within 1 year? So N is still 25, our P is still 0.05. This time we're looking for the probability at most means 6 or less. So X is less than or equal to 6. Because we're doing an inequality, this is when we're going to use binomial CDF. And on your formula sheet, it actually says NP, and then it says here max X. This just means it's the biggest value that X is allowed to be in your scenario. So in our scenario, the biggest our X can be is 6. So we would say that binomial CDF is going to be 25.05 and 6. Remember that it has to be in this format so that you know the biggest X value you can have. This one's already in that format for you, and it will be like that on your test, so that'll be nice. Make sure that you do go to the CDF one on your calculator, and the answer you get for this is 0.9998. Okay, again, make sure you write that part down. Okay, what is the probability that at least 2 visitors to the ER will die within a year? So at least 2 means, well, let me write this stuff down, N and P. At least 2 means 2 or more, right? So the probability that X is greater than or equal to 2. Okay, so because we see that this is greater than, remember we need it in this format, less than or equal to. So I need to rewrite this using the complement. So the complement would be 1 minus the probability that X is less than 2. Okay, well, that means if it's strictly less than 2, that 2 cannot be one of my values. So the maximum value that I can have for my X is 1, because this is a discrete case. Okay, you will have an at least 1 on there, so make sure you do know how to do this process. So we're going to use 1 minus binomial CDF, and we're going to put in our 25 and our 0.05. Don't forget the 1 minus, that part's really important. And then now, since this is in the correct format, we have the 1 there. Our maximum X value is 1. So when we type this in, then we're going to get 0.3576. Okay, here's your third extra credit question. The following data represent the travel time in minutes to school for 9 students enrolled in a college algebra course. Calculate the standard deviation for this population data set. Note, just a special note here, your key word is that this is a population. So make sure you do the proper notation. You look at the right thing on your calculator. Okay, use the following information for for problems 14 to 16. The probability that a randomly selected patient who visits the emergency room will die within 1 year of the visit is 0.05. In a random sample of 1,000 visitors to a particular emergency room, find the following. How many visitors are expected to die within the next year? So that expected word, remember that means expected value. So the expected value, also known as the mean, either one of those is fine. Like I said, you can do either one. Expected value for a binomial, because we did determine that this is binomial. Then the expected value for this, mu, is equal to n times p. So on your formula sheet, it does not show the e of x, but just knowing that those are, in fact, the same, e of x is the same as the mean. So when you see expected, it means expected value, the mean, and because it's binomial, we can use this formula. Mean equals n times p. So our n is 1,000 for this example. P is still that 0.05. So mu equals 1,000 times 0.05, which is 50. So we would say 50 visitors. Okay, so out of 1,000 people, you would expect 50 of them to die within the next year. Out of 1,000 people that visited the ER. So that's kind of sad. What is the standard deviation number of deaths? So again, it's binomial, so the standard deviation for a binomial is the square root of npq. So we know n is 1,000. We know p is 0.05, but to find q, we take 1 minus the p-value. So 0.95 is that one. So for my standard deviation, it's the square root of 1,000 times 0.05 times 0.95 equals, this ends up being, what did I get for this one? 6.9. You will round to 1 decimal place because that's what you always do, one more than what your data set is. So if our data set is whole numbers, because we're talking about people, you will round your mean and standard deviation to 1 decimal place. Okay. You will have questions exactly like these 3 as well. Let's see, a researcher finds that after 1 year, 68 of the 1,000 visitors have died. Do you think this particular emergency room should be investigated to see if something unusual is occurring? So when you see that keyword there of unusual, then when it's a binomial, unusual binomial, this is where we take the mu minus 2 sigma and the mu plus 2 sigma, and we want to see if that number 68 is in between those two, and if it is, then it would be considered usual. If it's outside of these two numbers, so if it's smaller than the mu minus 2 sigma or bigger than mu plus 2 sigma, then that means it's unusual. So mu in our example is 50 minus 2 times 6.9 equals 36.2. Okay, so 68 is not smaller than that, so that's good. But, well, I guess not really good. Probably would be actually, definitely wouldn't need to investigate them if less people than 36.2 are dying, you know. But if it's more than this, then we got a problem, right? So times 6.9. So this one equals 63.8. Uh-oh. So 68 is more than, 68 is more than, I'm going to say mu plus 2 sigma. So this is unusual. The question says, do you think they should be investigated? So I would investigate further. Okay, here's your fourth extra credit question. At Plano East Senior High School, the school records the grades for the whole senior class on a certain test and finds that the mean is a 78 with a standard deviation of 5.4. Isabel got a 97. What is Isabel's z-score? Interpret her z-score and determine if it would be considered unusual. Okay, so just like a little hint here, you'll need the formula to find a z-score, which was in chapter, what chapter was that? 3 on your formula sheet, chapter 3. Calculate her z-score, and then remember it's unusual, so just like we did here, it's unusual if it's more than 2 standard deviations away. So if her z-score is more than 2 standard deviations away, then that would be considered unusual. So also another little hint on that is that if you have, when you're talking about z-scores, you're talking about your standard normal. For z's, that means the mean is 0 and the standard deviation is 1. So more than 2 standard deviations away would be higher than 2 or lower than -2. So just keep that in mind. Okay. Use the following information for problem 17 and 19. Consider a binomial probability distribution with parameters n equals 8, p equals 0.75. Construct a binomial probability distribution with these parameters. Round all probabilities to 4 decimal places. Okay, because my n here is 8, then that means that I'm going to be going from 0 to 8 on here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. You will have a question like this. You won't have to go as high as 8, but you will have to do some of these. And my P is 0.75. So I showed you a little shortcut for doing all the probabilities over here, so that way you don't have to type each one of them. But the way you would find your first P, so for P of x, so when x is 0, oops, this just looks weird. Okay, let me try this again. When x is 0, then for this one you're going to do binom PDF, because we're doing exactly one value. My n is 8, my p is 0.75, and my x is this value here, 0. If you're doing it in the list 2, so if you do this as list, so list 1 is that column. For list 2, you're going to type in, you go up and highlight where it says L2, so that part should be in black. You put in binom PDF 8.75, and then here you would put L1. Then once you hit enter, it should populate all of your probabilities here. Okay, so when you write it on here, you'll notice that the first 2 end up being in scientific notation. So for 0, it ends up being, see, I don't really have enough space to write this because I wrote all this over here. Well, I just write it here. Actually, it is 1.5 times 10 to the -5th. So you move it 5 places to the left. 1, 2, 3, 4, 5. Fill in all your zeros. Since it says to round to 4 decimal places, here's the 4th one. Is that this 4th 0? And the 1 tells me to keep it the same. So this will be 0.0000. And then when you do the 1, that one comes out to be 3.6 times 10 to the -4th. So when you move it 4 places to the left, 1, 2, 3, 4. Then when you round this one, it becomes 0.0004 because that 6 tells me to keep the 3, or round the 3 up. I have to erase that because I don't have space. 0.0004. All the rest of these, 0.0038, 0.0231, 0.0865, 0.2076, 3115, 2670, 1001. If you manually type them into your list, you will get a little bit different answer on the next part. That's okay. I will account for those variations. So if you don't do this shortcut where you put the exact values in there, that's okay. You don't have to worry. So if you just manually type these numbers in, you may get a slightly different answer on the next few questions. Compute the mean and the standard deviation of the distribution. So for this one here, those will be actually separated into two different problems. But the mean, you're going to do the same thing that we did for the expected value with the list 1, list 2, and do your frequency list, right? So 1 var stats, you do list is list 1, and then frequency list is your list 2, and then you look at X bar for the mean. So when we look at that, we're going to get 6. And then you're going to look at sigma X for standard deviation. And that value, we're going to round to 1 decimal place, because that's what it says, is going to be 1.2. Graph the discrete probability distribution, comment on the shape. So what I told you, or what I'm telling you now, is that you'll just have like, it'll say skewed left, skewed right, or bell-shaped. And you'll just circle the correct one. So let's see here. These will all be, it'll be nice and set up for you so that you know what all you need to put on there. Nothing tricky about it. So make sure you put your 0 on the axis. 1, 2, 3. These will count up by 0.05. So 5%, 10%, 15, 20, 25, 30, 35. It says to label on your test. It says make sure to label the axes. So you'll just call this X, and you'll just call this probability of X. That's it. You don't have to do any extra stuff there. And then we'll graph our probabilities. So at 0, you're at 0. So 0, 0. At 1, you're pretty much at 0. It's 0.0004. At 2, you're at pretty much at 0. Okay, 3, you're going to be at about 0.023, so it's about halfway here. 4 is going to be at 0.0865, so 0.09 if you round it. So a little bit before this one. 5 is going to be about 0.21. And then 6 is going to be at 0.31. 7 will be at 0.27. And then 8 is going to be at 0.10. So right here at about 0.1. Okay, so when you look at the shape of your graph, it looks like you've got this long tail over here to the left. So this one is skewed left. All right, here's your 5th extra credit question. When babies go to the doctor for their well baby checkup, actually I just was there with my 3-year-old. No, she's 4 now. For her well child checkup. Anyways, babies go to the doctor for their well baby checkup. Their head circumference is recorded. Suppose Liam's head circumference is in the 80th percentile for 3-year-old males. Interpret this result. All you have to do is explain what that means. So give me the interpretation of what the 80th percentile means. in terms of head circumference. Make sure that you're specific on what you're talking about. Don't just say all babies. We're not talking about all babies. We're talking about 3-year-old males. So just keep that in mind when you're giving your explanation. Okay, chapter 7. Use the figure to answer questions. 20 to 23. What is mu? Okay, this is a very easy question. Remember, mu is always in the middle, your mean. So right here, this is all I'm looking for. And yes, you will have one like this on your test. And I believe, how many points did I make it? I made it worth 2 points. So that's an easy 2 points. Standard deviation. Okay, well, how far is it from 60 to 70? That's a plus 10. So your standard deviation is 10. That's another 2 points. Easy. Suppose that the area under the normal curve to the left of x equals 45 is 0.0668. Provide 2 interpretations for this area. You will need to do this. I will have this on here, and I'll actually put little numbers just like this, and then you just have to fill them in. So your first interpretation is the proportion. So we talk about in proportions. We say the proportion of values to the left, or we could say less than, of 45 is 0.0668. The only thing that will change in this question when you write like for a new problem, that's that. Everything else is going to stay the same. The proportion of values to the, and then you just insert whatever it is for your problem. And then for the second one, the probability of randomly selecting a value less than 45 is 0.0668. Okay, so for this one, the only part that's going to change is that probability of randomly selecting a value, and then insert your problem. Okay. All right. Suppose that the area under the normal curve between x equals 50 and x equals 75 is 0.07745. Provide 2 interpretations for this area. Okay. I'll give you a hint. There's only one of these on the test, and it's the previous one. But I will also give you these interpretations. So the first one, the proportion of values between 50 and 75 is 0.7745. The probability of randomly selecting a value between 50 and 75 is 0.7745. So again, the only part that changed, this part, that part. Okay. Next one. Okay, draw, sorry, I'm on the wrong page here. Here we go. Draw a standard normal curve. Okay, you don't have to draw it, it's already there. And shade the area indicated. Then find the area of the shaded region. So part of your credit is going to come from your shading. Note that this is the standard normal curve, which means we're talking about terms, and we're in terms of z. And when we're in terms of z, that means that our mean, whoopsie, clearly didn't change that. Our mean is going to be 0 and the standard deviation is going to be 1. That's just what it is for the standard normal curve. Okay, so the area to the left. So we're going to start by, because we're in terms of z, we're going to put 0 right in the middle. That's what I will be looking for that. And then you're going to put your negative 1.04 on your graph. Well, negative numbers should be to the left of 0. And it says the area to the left. So we're going to shade the area to the left of this. Okay, because this is the normal curve, this means we're going to be using normal CDF, always the CDF for this stuff, because we're finding a continuous amount of values. We're not finding just one value. That's why the CDF. And we are always going to do left to right. So my lower bound, so farthest left, left to right. So on the left here, I'm going to put negative infinity. So negative 1e99. The farthest right number is negative 1.04. And then we follow that with mean and then standard deviation. So on your formula sheet, it does say normal CDF, and it says min x, max x. So the smallest x, it says min x, max x, mean, standard deviation. Okay, so when you type that in, you're going to get 0.1492. Okay, this number here is the area shaded to the left. Okay, so when you're looking for area, use normal CDF. If you're given area, use inverse norm. Okay, so the area to the right of z, so again, we'll put our mean 0 in the middle. Z, 1.37 should be way over here, 1.37. And then it says the area to the right. Okay, so area to the right, we're going to do normal CDF. I'll get rid of that for a minute. Normal CDF, my minimum x value, or z value in this case, is 1.37. My maximum is 1e99, 0 and 1. So when we type that into the calculator, we get 0.0853. So that's the area shaded to the right. Okay, you will have one of each of those. So, uh-oh. Did I lock my screen? Oh, I accidentally locked my screen. Did I finish this page? No. Okay, I almost missed the rest of this page. Okay, so extra credit number 6. It says, a professor wants to study the relationship between number of days absent from a class and the final grade in the class. Interesting. The table below presents the number of days absent and the final grade for a sample of college students in a statistics course at Collin College. So here's the number of absence listed across the top here, and then the final grade is over here. So if they had 0 absences, their final grade was 89.2. 1 absence, this. Find the correlation coefficient and determine whether there is a linear relationship between the two variables. If a linear relationship exists, find the equation of the least squares regression line. If no linear relationship exists, state no linear relationship. Okay, so find the correlation coefficient. This is chapter 4. Okay, so go back to your chapter 4 stuff and find out what correlation coefficient means. And then also the least squares regression line. Okay, maybe a hint, there's something about an R, something about a Y hat. Okay, and then also there's multiple questions here. So once you find that R, you need to determine if there's a linear relationship. So you have to compare it to your critical value. You have to. That's part of it. So make sure you show that step. Okay. Next page. Find the requested values. Find the z-score such that the area to the left of the z-score is 0.4830. Okay, so if you're given area, now I'll write it over here. Given area, use inverse norm. Okay, so this time it says the area to the left, which is really great news for us because we need it to be area to the left. Is this. Okay. Oh my gosh. I tell you what. Okay, so once again, we're still talking about z's, so 0's in the middle. Now, if it says my area to the left is this, remember, think of this as a percentage. This is like 48.3%. Okay, so if I know that this mean here cuts this in half, 50%, 50%, then on the left side, I don't need this whole 50%. I need only 48.3% of it. So that means that the z I'm looking for should be just slightly to the left of my 0. Because I don't need the whole 50%, only 48.3%. So just a little bit gets left out. Okay, and we're shading to the left, so all of this, and it tells me that this area is the 0.4830. Okay, and I'm looking for z. So we're going to use inverse norm, and in order to use inverse norm, it has to be area to the left. So again, on your formula sheet, it actually says area to the left, so it'll tell you that part. But our area to the left, which was given, 0.4830, and then mean standard deviation. Okay, still because it's the z-scores, mean is 0, standard deviation is 1. So when we plug this in, we get negative z equals negative 0.04. Okay, let me see. Yes, you have one like this, and like 27. Find the value of z 0.20. Okay, so remember that this number right here, that's giving you the area to the right. Okay, I know it makes it confusing. Of course, this is area to the right. Okay, so when we shade here, what this tells me is z sub 0.20 is the area to the right of my z value. So if 20% is shaded to the right, remember this is 50%, so I'm not going to go all the way to the 50%. It's going to be pretty far over here because only 20% of this is going to be shaded. The other 30% will be here, right? So 20% to the right, so this is my z sub 20, and I'm shading to the right here. But in order to use the inverse norm, I need to know the area to the left. So the area to the right, oops, I didn't label it, this 0.20, but my area to the left, all of this stuff, this is 0.80, 80%, 20%, right? So when I type this into my inverse norm, my area to the left is the 0.8001 mean standard deviation. So when we type that in, we should get 0.84. And I will say z equals. Okay, so you will have one like that. Okay, here's your 7th extra credit question. Suppose that you have the following data. N equals 5, R equals 0.719, Y hat equals this equation, and Y bar equals 3.7. Decide if the variables are linearly related, then make the best prediction for Y when X equals 9. Okay, critical value, once again, make sure you look at those critical value. That's chapter 4 also. Okay, use the following information for problems 28 through 31. Suppose that Dunlop Tire manufactures a tire with a lifetime that approximately follows a normal distribution So that means we're going to use our bell curve. Mean of 70,000 miles. Standard deviation 4,400 miles. So let me write that over here. Mean is 70,000. Standard deviation 4,400. Okay. What proportion of the tires will last at least 75,000 miles? Okay, so let's start by labeling. Right in the middle goes our mean. This time it's not 0 because we're not in the standard normal. This is still a normal distribution, but it's not the standard, and we're not in terms of z, we're in terms of x now. So our mean is 70,000, so that goes in the middle. Okay, and then it says 75,000, that's going to be over here, will last at least 75,000. Now, at least 75 means 75,000 or more, right? So that's to the right. I want to know this area right here. The picture is going to be really helpful for you in setting up your inequality. I'm sorry, not your inequality, your normal CDF. All right, so this would be normal CDF. My minimum x value is the 75,000. The maximum would be infinity. Then my mean is 70,000. My standard deviation 4,400. So when you type all of that in, we get 0.1279. So that's the proportion. If you want to, you can write that as a percentage. I mean, you could say also 12.79%. I don't care. Either way you want to write it, it's up to you. Suppose that Dunlop warrants the tires for 60,000 miles. What proportion of the tires will last 60,000 miles or less? Okay, so 70,000 is still our mean. And 60,000 is going to be way over here. Okay. And it says, what proportion of the tires will last 60,000 miles or less? So that's this way. So again, we're going to do our normal CDF. My minimum x value this time is negative infinity. My maximum, 60,000. And then my mean, my standard deviation. I want to caution you, be really careful when you're typing all this in. There's a lot of zeros. Don't accidentally miss a 0. I mean, if you miss a 0, it really will mess up your whole answer. So just be extra careful when you type it in to make sure you got all those zeros in there. Okay, so when we type this one in, we're going to get 0.0115. Okay. There we go. Let's see. So if you're wondering about those, let's see, at least, yep, you got one of those. Miles or less. Yeah, you got a less than one. Okay. What is the probability that a randomly selected Dunlop tire lasts between 65,000 and 80,000 miles? You'll have one of these. So again, our mean was 70,000. Need to write that up here. Mean is 70,000. Standard deviation was the 4,400. Okay, so between 65,000 and 80,000. So 65,000 would be about here. And then 80,000 probably over here. Okay, and we're going to shade in between. Okay, so when we do our normal CDF for this one, the minimum value, 65,000. The maximum value, 80,000. Our mean, 70,000. Standard deviation, 4,400. And then when we plug that in the calculator, we will get 0.8606. So yes, you'll have one like this. Suppose that Dunlop wants to warrant no more than 2% of its tires. What mileage should the company advertise as its warranty mileage? Okay, so if you're given the percentage, right? This is the same as being given the area. Okay, no more than 2%. In other words, this is 0.02. So they want to warrant no more than 2% of their tires. So they need to know the mileage that they should state as their warranty mileage. So right here in the middle, this is the average. Okay, so they want 2% or less of their tires. Okay, so over here, that means this really small amount here. They want this value to be their 0.02. That's their 2% or less. And we want to know, what is this x value here? So when we're given the area or a percentage like this, we're going to use the inverse norm. And we're looking for area to the left. So area to the left would be 0.02. And then we're going to give our mean, which is 70,000, and our standard deviation, 4,400. Okay. But this one, it's going to give us 60,963.5. So the question is, what's the mileage they should warrant? So if they did 60,964, technically that would be a little bit more than 2%, right? Because you'd be going up over into this range, so it's a little more than 2% that would be shaded. But if you round down, you're going to be a little bit less than 2%. So for this answer, you really technically should round down. If you round it up, I would not count it wrong. But I just wanted you to be aware of why. Let's see here. I will have one similar to this. Yes. Okay, extra credit, number 8. At a certain convenience store, the probability that a customer buys a pack of gum is 0.37. If 10 people are randomly selected, what is the probability that all 10 purchase a pack of gum? Okay. Pay special attention to the fact that it says all 10. Okay, these are independent, okay, because they're randomly selected. So look back in your chapter 5 notes. That's chapter 5. Let's talk about probability. What did we do when it said all of something did whatever? Okay. That was one on the test. It was about the Dallas Cowboys that a lot of people missed. So go back and revisit how to do that problem. Okay, use the following information for problems 32 to 37. The Wechsler Intelligence Scale for children is approximately normally distributed, with mean 100 and standard deviation 15. What is the probability that a randomly selected test taker will score above a 125? Okay, so again, normally distributed. There's that. And our mean is 100. Standard deviation is 15. Okay, sorry. Dying over here. Okay. Mean is 100. Randomly selected test taker will score above. Okay, so here, above 125. So we need to put that on here. So 125 is going to be like pretty far over here, I would say. Since the standard deviation is only 15, 115 would be about here. Maybe not quite that far. But they said above. It's this area here. Okay, so if we're looking for the probability of being above, again, this is a normal CDF. From 125 would be my minimum. My maximum value would be infinity. My mean is 100. My standard deviation is 15. So if we plug that in, we're going to get 0.0478. Okay. What is the probability that a randomly selected test taker will score below a 90? Okay. So below a 90, here's 90, about there. Below would be this way. So our minimum x value is the negative 1e99. Highest, your maximum x is 90. Mean is 100. Standard deviation 15. Okay, that answer would be 0.2525. Okay, so these are quite similar to the ones with the tires, so you're not going to see more than one. What proportion of test takers will score between 110 and 140? So there's your 100. So 110 is going to be over on this side. 140 over here. And we're going to shade in between. So again, normal CDF. My minimum x is going to be that 110. My maximum, 140. Mean is 100. Standard deviation, 15. That answer is 0.2487. You could also write it as a percentage if you wanted to. For any of these, you could. Okay. If a child is randomly selected, what is the, by the way, yeah, those three, like I said, you've already kind of seen them, so I'm not going to put them on there twice. If a child is randomly selected, what is the probability that she scores above a 150? Okay. So here's your 100. Mean is 100. Standard deviation is 15. So 150 is like way over here. So that's like a really tiny area. That right there. And the question is, what's the probability that they're above the 150? So again, normal CDF. Minimum value is 150, the maximum infinity. And then mean is 100, standard deviation 15. So that answer is 0.0004. So quite small, very small probability. What intelligence score will place a child in the 98th percentile? Well, this is going to give you a little bit of a hint on that extra credit question. We're talking about the 98th percentile. Let me put my mean here in the middle. 98th percentile means that 98% are below whatever that score is. So that score is going to be pretty far over here. We want to know this score where 98% are below. So if I shade all of this, that whole area should be 0.98. Okay, so this time we're given a percentage, right? Or a percentile. This means we're given the area. So we are going to use inverse norm. And my area to the left, remember, is 0.98, so that's handy. And then my mean is 100, my standard deviation 15. So when we calculate that, we get 130.8. So to be in the 98th percentile, I would just go ahead and round this one up to 131, like normal. I would accept either 130 or 131. Either one of those would be fine. So make sure you can do the percentile. You'll have one like that as well. Okay, and then let's see here. If normal intelligence is defined as scoring in the middle 95% of all test takers. Yes, I have one like this too. The middle 95% of all test takers. Figure out the scores that differentiate normal intelligence from abnormal intelligence. Okay, so your mean, again, 100. So if it says the middle 95%, that means I'm going to cut this like here and here. So all of this area here in the middle is 0.95. Okay, that means that my area to the left over here and to the right have to add up to 5%. And half of 5% is 2.5%. In other words, this is 0.025. This one over here is also 0.025, but I mean, we really don't need that number, but I will go ahead and put it here. Okay, so when I'm looking for these values, I'm going to call this x1 and this one x2. For x1, I'm given the area to the left. Well, actually, I found the area to the left. So, again, you see that percentage, right? So that means you're going to use that inverse norm. My area to the left of x1 is the 0.025. And then my mean is 100, my standard deviation, 15. So when I calculate that value, I get 71, well, 70.6. And then I went ahead and rounded that to 71. And then for x2, I have to do inverse norm also, but my area to the left of x2 is all the purple region plus the red region. So that's going to be 0.975, 115 there. Okay, when we calculate that, we should get 129.4, which we can round to 129. Okay, so that would be your cutoff scores that would differentiate the normal intelligence from the abnormal intelligence. Okay, here's your 9th extra credit question. Whoops. Try that again. Use the following table for questions 9 and 10. It says adult Americans were asked whether they used social media regularly. The following table is based on the results of the survey. So these are their ages up here. 18 to 34, 35 to 44, 45 to 54, and 55 plus. And then over here, they use social media or they do not use social media. An adult American is randomly selected from this group. What is the probability that the adult is 35 to 44 or does not use social media? Your keyword there is or. Okay, I'll leave it at that. Make sure you look on your formula sheet, chapter 5, for the probability formulas. That'll help you with that. Okay. Chapter 8, use the following information for problems 40, oops, must have missed that. I need to fix that. Problems 38, oops. (38 to 40) is what that should say. I'll fix that. Okay. The length of human pregnancies is approximately normally distributed with mean of 266 days and standard deviation 16 days. What is the probability that one randomly selected pregnancy lasts less than 260 days? Okay, so some keywords. One, less than. Okay. So let's see here. Our mean is going to be 266. 260 is going to be over on this side. Pretty close. And I'm going to be shading to the left because it says less than. Okay. So for this one, because this is just one person, we can do the normal CDF the way we've already been doing it this whole time. So my minimum X value is -1e99. My maximum is 260. The mean is 266, and the standard deviation 16. Okay. So when we calculate this, we should get 0.3538. Okay, so that's, I mean, nothing spectacular there, because it's only one person. Now, when I go to the next part, which says, what is the probability that a random sample of 20? Okay, so now we're dealing with a random sample. So when I told you, if you see that you have a sample of 20 has a mean gestation period of 260 days or less. So here, this is going to be 266 is our mean, I believe. The standard deviation was 16. Now, because we have a sample of size 20, that means we have an n equals 20. So for that one, if you look on your formula sheet, you'll see that it's under the central limit theorem. So we would use the normal CDF, and it's going to be your low to high, and it'll say mean, and then standard deviation divided by the square root of n. Okay, so it's a little bit confusing on the formula sheet as I'm looking at it now, but just remember, you just need to remember this formula. So, okay, so now let me put my 260 over here. So mean gestation period of 260 or less. So same shading as the previous problem, and it will be like that on your test too. I'm not doing weird trick stuff. Okay, so we will put in normal CDF. My minimum value is -1e99. My maximum 260. My mean is 266. And then we're going to do our standard deviation, which is 16 divided by the square root of 20. You'll just type that in your calculator that way, and you will get 0.046. That would be an 8. And that's it for that one. You won't have one like number 40 because it's pretty much the same as before, except that now the random sample is of size 50. So, oops. So it still says the same kind of thing, because I mean it's the same exact question except different random sample size. Sample of 50, mean 260 days or less. Okay, so same picture, same shading, same setup. Negative infinity, 260, mean is 266, and then here we would have 16 over the square root of 50 this time. So let me write my stuff here. N would be 50. Okay, so then when we solve that one, we would get 0.0040. Okay, so that's it for the review. The last extra credit question, I put the table again, just in case you need to see it a second time. And it says, this time, what is the probability that the adult American uses social media given that the adult is 55 plus? So, keyword given. Again, make sure you look back at your formula sheets. And that concludes this review video.